the defense systems of the aircraft carrier USS Gerald R. What would happen if a single aircraft carrier could withstand a coordinated air attack, sea and subsoil? Today we reveal why the USS Gerald R. Ford is considered by many analysts to be the most difficult warship to destroy on the planet. Before we begin, if you enjoy these high-impact analyses, please like and subscribe, because today we're entering territory where engineering and military strategy merge. When the U.S. Navy officially unveiled the aircraft carrier USS Gerald R. Ford, it made it clear that this was not simply an evolution of previous models. This ship was born with a mission: to become the backbone of American naval power for decades to come. And that goal can only be achieved if the aircraft carrier is virtually undetectable, incredibly resilient, and capable of operating even under massive attack. The first key element is its reduced radar signature. Although it displaces more than 100,000 tons, the Gerald Ford structure has been designed to scatter radar waves. This means that, from long distances, the giant can appear smaller on enemy screens. The intention is not to completely conceal itself, but to complicate the guidance of anti-ship missiles that rely on electromagnetic signatures. The second piece of its shield is its sensor network. On board, active array radars, infrared sensors, and electronic surveillance equipment scan the environment across multiple spectra simultaneously. This combination creates what many specialists call a situational awareness bubble. Within it, every aircraft, drone, missile, or vessel moving within a radius of hundreds of kilometers is detected, classified, and monitored. However, the most impressive aspect isn't the sensors themselves, but the software that coordinates them. The Gerald Ford's combat system can process thousands of data points per second and automatically prioritize threats. In a saturated attack scenario, dozens of kamikaze drones, cruise missiles, and torpedoes launched almost simultaneously, the system doesn't get confused. It decides what should be destroyed, what should be electronically deceived, and what should simply be monitored. In terms of active defense, the aircraft carrier incorporates CRAM, an autonomous station that detects short-range threats and fires missiles specially designed to intercept projectiles that have already entered their terminal phase. In addition, the ship is equipped with a Phalanx CIWS, a 20mm battery capable of firing between 3,000 and 4,500 rounds per minute, creating a nearly impenetrable wall of tungsten. Furthermore, the Gerald Ford is not limited to destroying threats, it can deceive them. Its electronic warfare systems are capable of jamming enemy radars, interfering with signals, manipulating thermal signatures, and activating decoys that disorient even advanced missiles. Structurally, it also possesses passive defenses, airtight compartments, automatic fire suppression systems, and redundant power lines. If an impact causes damage, the aircraft carrier can continue operating while other sections are isolated and repaired. All these components make the USS Gerald R. Ford a floating fortress designed not only to survive, but to maintain the initiative even in the most intense attacks. It is, without a doubt, one of the most heavily protected ships ever built. Although the Gerald Ford's main strength lies in its air wing, its offensive systems and complementary defensive capabilities make it a crucial player within any battle group. One of its key components is the ESSM, Evolved Sea Sparrow Missile System, a short to medium-range missile designed to intercept extremely fast-moving threats. This projectile is effective against modern anti-ship missiles that perform evasive maneuvers in the final seconds of flight. Alongside it operates the SM-6, considered one of the most versatile missiles in the U.S. Navy. It can shoot down aircraft, intercept terminal-stage ballistic missiles, and neutralize surface targets. Its main advantage is its link with external sensors. It can receive data from radars located on nearby destroyers or even AWACS aircraft, greatly expanding its operational range. But the true power of the Gerald Ford emerges when its full integration with the entire fleet is analyzed. Through the cooperative combat system, the aircraft carrier can detect threats that are physically beyond its own radar range. If an Arleigh Burke destroyer detects a missile at 450 kilometers, that information is transmitted instantly to the Gerald Ford, which can react without having seen the target directly. On the offensive front, its air wing is its greatest weapon. The F/A-18 Super Hornet fighters and the future F-35C, they provide air superiority, precision strikes, and advanced surveillance. MH-60R helicopters enhance anti-submarine capabilities, while MQ-25 Stingray drones increase the fleet's range and airtime by providing aerial refueling. The ship also incorporates the revolutionary EMALS, electromagnetic catapults that replace traditional steam systems. This not only reduces vibrations and wear, but also allows for the launch of heavier aircraft, faster and with fewer personnel. In an emergency, this responsiveness can be the difference between repelling an attack and being left exposed. In addition, the Gerald Ford features weapons elevators that operate using electromagnetic technology, speeding up ammunition loading and minimizing risks. Every element of the design aims to maximize efficiency, speed, and resilience. Together, these systems transform the Gerald Ford not just into an aircraft carrier, but into a mobile command center capable of directing operations in the air, at sea, and underground. Its role extends far beyond direct combat. It is the brain of a highly synchronized military ecosystem. While many nations are developing hypersonic missiles, directed energy weapons, and autonomous drones, the USS Gerald R. Ford is preparing to become the first aircraft carrier designed to operate fully within this new warfare paradigm. Its infrastructure is not static. It was built to integrate future technologies without requiring complete overhauls. One of the most promising developments is the incorporation of laser weapons. In a world where swarms of drones can overwhelm traditional defenses, lasers represent an effective and low-cost solution. Connected to their nuclear reactors, these systems could fire thousands of times without the need for physical ammunition. The Gerald Ford already has reserved space, wiring, and structural support to install high-energy lasers within the next decade. In parallel, the U.S. Navy is working on defensive drones launched from aircraft carriers. These drones would perform interception, reconnaissance, and electronic warfare functions, acting as a mobile shield capable of expanding or retracting depending on the threat. Their mission is to confront threats before they even approach the fleet. The integration of quantum radars is also being explored. These systems are capable of detecting stealth aircraft using principles of quantum entanglement. Although still experimental, these sensors could redefine how threats are detected over long distances. Another key trend is distributed warfare. In future conflicts, an aircraft carrier will not be enough. It will not act as an isolated target, but as a node within a network of ships, naval drones, and unmanned submarines. The Gerald Ford will be able to command them from hundreds of kilometers away, creating an extended battlefield where information flows instantaneously. And so we conclude this in-depth analysis of the most advanced aircraft carrier ever built. If you enjoyed this report, give it a like, subscribe, and turn on notifications, because we'll be back, exploring the military technologies that are changing the course of the world. See you in the next video, Commander.